Hey everyone, let's take a look at number 9 here in section 7.5. We're going to evaluate the following integral using first substitution and then partial fractions. Um, Here's the integral. Integral secant squared divided by tangent squared minus 25. Okay, so what might a substitution be here? Um, well, you could think maybe I'll let u be the entire denominator here. Tangent squared theta minus 25. However, the derivative, of course, of 25 is 0. But the derivative of tangent squared theta, we've got a chain rule, right? Because that's tangent theta quantity squared. So that would be 2 times tangent theta times the derivative of tangent theta, which is secant squared theta. And we don't have an extra tangent theta up here. So that's not quite going to work. However, if I let u be tangent theta, notice what we have up top here, secant squared theta d theta. That's exactly what our du is, right? And so notice the numerator, secant squared theta d theta, becomes the du. And in the bottom, tangent squared now is u squared, and then of course minus 25. So now hopefully you see why they said now after the substitution use partial fraction. So I'm going to break up this, which was really, remember, 1 over u squared minus 25 into its partial fraction decomposition. So we factor, this is just the difference of squares. And so I have one linear factor of u plus 5. That gives me this fraction, right, in the decomposition. And then u minus 5 gives me this fraction. Multiply both sides by this least common denominator of u plus 5 times u minus 5 on both sides of this equation. Over here, I just get 1. Here, the u plus 5s will cancel, leaving me a times u minus 5. And here, the u minus 5s will cancel, leaving b times u plus 5. So I'm going to use my little shortcuts here. If u is equal to 5 in this equation, notice what happens. I get 1 equals what? Well, if I plug in 5 here, this is 0, so that goes away. And this becomes b. 5 plus 5 is 10. I get 10b, so b must be 1/10. Similarly, if u is negative 5, I get 1 equals a times negative 10 or negative 10a. This is 0, and I get a is negative 1/10. So going back to our original integral here, well, the integral after the substitution, that is, we want to integrate a plus a over u plus 5 plus b over u minus 5. I'm going to change the order simply because b is positive, a is negative. So I'm going to bring this fraction in front. B is 1/10 over u minus 5, and then plus a over u plus 5, but a is negative 10, so plus or minus is negative 1/10 over u plus 5. So now we can find the antiderivative, right? The antiderivative of this first fraction, the 1/10, can come out as a constant multiple. And right, 1 over u minus 5, if I let w be u minus 5, dw is du, and I get 1 over w. Antiderivative is the natural log of w. And so we get the natural log, of course, absolute value of w, where w is u minus 5 times that 1/10. Similarly, the antiderivative of 1/10 over u plus 5 is 1/10 the natural log of the absolute value of u plus 5. This is not the final answer, though. Remember the u, we did a little substitution to get here. If you remember, u was tangent theta. We want to go back to the original variable. Here's our original integral in terms of theta. So to go back to the original variable theta, I let u be tangent theta, and I get this down here as my answer. I edited in blue what I think Achieve wants you to have. Um, Parentheses around the argument for the tangent function, and then they've got this weird, you got the absolute value. They want to have the parentheses around that, I think, for it to work. So at any rate, this is the result, and I hope this is helpful here. Interesting use of substitution and then partial fraction decomposition.